Section 8.2 works with multiplying and dividing rational expressions. We're going to go through our processes for how we do each of these and some examples that go along with them. So the big thing we want to note when we are actually working with this multiplication and division with rational expressions is that we are going to be treating this multiplying and dividing process the same as if we were multiplying and dividing fractions. That's essentially what we're doing. So as we have here in the multiplication one, if we look at the idea of A, B, C, and D being real polynomials, whatever they may be, if I'm going to multiply this rational expression with this rational expression, we can see I'm doing the same thing as if I were multiplying fractions. I'm multiplying the numerators together straight across, I'm multiplying the denominators together straight across. And all I'm getting with my result is A times C over B times D. Again, A, B, C, and D are polynomials in this instance, but I'm essentially doing the exact same thing I would if these were just standard fractions like 1/2 and 3/4, or 5/8 and 11/10, something to that effect. Now for our process with multiplying, I'd recommend writing these out for ourselves here. So these are our three main steps that we have with this. Our step 0, which is listed as a step 0 because it is technically optional, but I would highly recommend that we start with fully factoring the numerator and the denominator of all fractions. The reason we want to do this is because, similar to when we have fractions multiplying together, we could do cross cancellation. Well, that same thing is available to us now, and we can cross cancel parts of these fully factored polynomials. And we are welcome to do that in this step 0. But that requires us to first fully factor everything. Remember, in previous sections, we have to factor, then cancel. Fully factor all numerators, fully factor all denominators, then and only then can we cancel anything out. If you would like to do that, you can. We'll go through an example so we can see here where you're going to be able to see that a bit more clearly. But you don't have to in that step. Step 1 is then telling us, I'm going to multiply the fractions together to create a single one fraction where everything in the numerator and denominator is multiplying together. It should be noted here, you want to circle, underline, star, highlight, whatever it may be. Absolutely do not do any kind of distribution when you're doing this step. The entire goal of step 1 here is to, instead of having things written as two fractions, I want it written as one single fraction, essentially creating an 8.1 problem. So once we have everything together as a single fraction, then we can fully simplify the rational expression. And the way we do that, again, is we're going to fully factor everything and then cancel things out. So if you're noting here and you're thinking, well, hold on, didn't we fully factor in this step 0? Yes. And this is why this is an optional one, the step that we can take, is because you are eventually going to have to do this. Your choice is either to do it at the very beginning of the problem or at the very end, but it's going to show up somewhere in this problem, in this process. So when we do this, we can leave the denominator of our answers fully factored. A lot of problems in books and resources will sometimes show them, I think it's about 50-50. Sometimes it's fully factored for the denominator, sometimes it's everything multiplied out. For the purposes of this class, you can leave the denominator fully factored. You do not need to multiply everything together. That same thing goes for the numerator as well, though we tend to see the numerator cancel out a lot more often than the denominator does. Either way, a fully factored form answer in the numerator and the denominator spot is perfectly acceptable for this class. So we are going to take a look at our first two examples here in a bit more detail and see how we get to our answers using the process written here. Our first example that we have here is the rational expression 2x minus 5y over 7xy times 35x squared over 25y minus 10x. So looking at the process that we had previously, we are going to go through this example assuming that we aren't going to do that step 0. We'll do that with our second problem because I think it lends itself to that more. So we're just going to start at step 1. So we're going to multiply the fractions together to create a single fraction where everything in the numerator is multiplying together and everything in the denominator is multiplying together as well. So I'm doing a rewrite step here. My recommendation when you are doing this is putting the first numerator in parentheses, putting the second numerator in parentheses, just so we know that everything is staying separated. And we're following that same pattern with the denominators as well. So now we can see here that everything is written as a single fraction with two things multiplying together in the numerator, two things multiplying in the denominator. I personally like writing monomials, things that have just a single term in them, in front of things that are binomials or trinomials where I have multiple terms here. So I'm going to do a rewrite of the numerator and put the numerator, or the monomial, I should say, out front, and the polynomials with multiple terms in back. This is just a personal preference thing. You do not need to do this for your problems. It's just something I find helps keep things a bit more organized. So there's step 1. It's all together as one single expression now. So step 2, fully simplify the rational expression. Now remember, with simplifying, we need to look to see, can we factor anything and then simplify anything out. Now the reason I like putting the monomials first in the numerator and the denominator spots is because I can't actually factor anything out of monomials, and I can just directly look to these things and say, well, hold on, I can factor, or I can cancel, I should say, 35 and a 7. I can cancel x squared and x down a little bit. So let's go through that. 35 and 7 can both be reduced by 7. So this 35 becomes a 5, this 7 becomes a 1. And then this x and x squared, they can each cancel a single x out. There's going to be a 1 left over in the denominator spot, and there's a single x left over in the numerator spot. And now I'm going to rewrite this thing because I've canceled some stuff. I've not fully canceled this thing, but I have it at least a little reduced. And now we have something that it's not fully reduced and simplified, but it's at least a little bit closer to being like that. Or at the very least, let's put it this way, at the very least our monomials are fully simplified. Now I need to look at my binomials and see what I can do here. I'm looking at the denominator, and I'm noticing I can factor something out from both of those terms, and that something is going to be a 5. So in the denominator spot, I'm going to factor out a 5 from the denominator. So that 25y minus 10x is going to become 5y minus 2x. Nothing changed in the numerator spot or anywhere else in this problem, so I'm just writing everything else in as it was. And now I'm looking at this and noticing, well, hold on, this 2x minus 5y looks really, really similar to what I have down here in this denominator, this 5y minus 2x. I'm noticing that I have 5y and 5y, but the denominator one's a positive, the numerator one is a negative. If I look at the 2x's, I see positive 2x up top, negative 2x down below. So each term is equal to one another, but the signs are the opposite. So the way I'm going to fix that is I'm going to factor one more thing out. I'm going to go from the denominator because I think it's easier to flip these ones here. I'm going to factor a negative 1 out from that as well. Now, factoring a negative 1 only changes the signs of what I've been given. And if I factor out a negative 1, that 5, which was originally positive out front right here, is now going to become a negative 5. Oops. Because that negative 1 would multiply with the 5, and we get a positive, right, a negative number showing up there. And now I'm noticing, well, now I have 2x minus 5 up top. I have 2x minus 5 down below. Now I can cancel those things out. That entire thing cancels there. Excellent. Well, what else do I have? Well, I'm looking in the numerator spot, and I'm seeing I have a 5 up top and a 5 down below. Each of those become 1s. The denominator is technically a negative 1. Let me go ahead and move us up here as I'm running out of space. And let's rewrite this thing. What's our new fraction looking like? I think it's very good practice to take these extra lines and rewrite what we have here. A lot of people try and keep track of all of this stuff at once. I don't think that's very easy to do. So take the extra steps as necessary to rewrite these things if you need to. So my numerator is now just x up top, and I have y times negative 1 down below. Everything else over here becomes 1, so it effectively cancels and kind of merges with everything else that we've been given. So now this thing looks much, much nicer to work with, and I can simplify this down. I have an x up top, can't do anything with that. Y down below, can't do anything with that. I have a positive up top divided by a negative down below, which means I'm going to get a negative answer. And the final fraction, or rational expression, is going to be a negative x divided by y. Again, I'm always checking to see, can I factor and simplify and reduce this thing any further? But I can't. So therefore, I've done everything I possibly can with example 1. Looking at example 2, we're going to go through and use all quote-unquote 3 steps of our multiplying process. So step 0 has technically been done for us at the start of this problem, but it's going to illustrate some of the advantages that we have with doing this at the very beginning. So we see here we have a fully factored first rational expression, and we have a fully factored second rational expression here. Now the advantage to doing this is this opens up the possibility of us using cross cancellation to cancel something out from a numerator and denominator spot somewhere in this problem as necessary. I want to emphasize we can only do cross cancellation if we have a fraction multiplying with another fraction. This cross cancellation cannot be done with addition, it cannot be done with subtraction, and it cannot be done with division. It is a property that is unique only to two things, or two rational expressions multiplying together. If anything other than that is taking place, then you cannot use this cancellation technique. So cross cancellation says I'm looking at all of the numerators, or all the things in the numerator spot. I'm looking at all of the things in the denominator spot, and I'm seeing, is there anything in any of the numerators that's the exact same as anything in any of the denominators that can cancel out? If we're looking at this, we're noticing, well, I have an x minus 3 and x plus 3 and an x plus 3. So each of those cancels out, and those become 1. Well, is there anything else in there? Well, I'm also seeing that I have an x minus 1 and an x minus 1 that can each cancel out. So that's good. I'm also seeing that there's an x plus 5 and there's another x plus 5 showing up in there, so those can cancel out as well. So we had a whole bunch of things just cancel. And again, I think it's very good practice to do a rewrite before you do anything else. I think 2, maybe 3 cancellations in one step is about the most you can do without potentially losing track of your work. So lose track, just keep everything together. Let's rewrite this thing. So the first rational expression just becomes 1 over 1. I have 1 times 1 up top. I have 1 times 1 down below. So we get 1 over 1 for the first rational expression. The second thing, the second one over here, ends up becoming 2x over x minus 2. The 1's multiply to those, and 1 times anything is just the original thing. And now we'll look at this and say, well, I can't really do a whole lot else with this in terms of cross-cancellation at all. So I multiply this thing together, and we multiply fractions straight across. Numerators multiplying together, denominators multiplying together. And we notice, well, 1 times anything is just the anything. So 1 times 2x is going to be 2x in the numerator spot. And then 1 times the quantity x minus 2 in the denominator. So I get x minus 2 down below. Now again, we always look to see, can I factor anything out of the numerator? Can I factor anything out of the denominator? No, I can't, so I cannot cancel anything else out here. A lot of people try and think, oh, I've got an x up top and an x down below. I could cancel those. Oh, I have a 2 up top. I have a 2 down below. I could cancel those. Remember, you absolutely must factor first, then cancel. If you cannot factor anything out, you cannot cancel anything out. We can absolutely never pick and choose just individual parts of the numerator, parts of the denominator to cancel out as we see fit. It must be factor, then cancel. The order it goes in. So because we can't do that, we can't go any further than this with simplifying this down and multiplying things together. So here we have our final answer of 2x over x minus 2. The second part of 8.2 is going to have us working with dividing rational expressions. So just like we've done with multiplying rational expressions, in the sense of we're going to do what we did with fractions, with rational expressions, we're going to do the exact same thing that we do with fractions with rational expressions here. So our general case that we see here, and this is just a quick depiction of it, let's assume we have the polynomials a, b, c, and d, whatever those might be. So we start off here with seeing I have one rational expression divided by another rational expression. What I'm going to do is actually never do this division process. We are instead going to rewrite this thing that we've been given into a multiplication problem. The way we do that is we identify where's the division sign, we flip that division sign, and we flip the rational expression that comes directly after that. It should be noted that there is no cancellation, there is no factoring, there is nothing other than a rewrite going on between this step and this step. Really want to emphasize that because a lot of people want to start factoring in canceling at the very beginning of these problems. You absolutely need to avoid that temptation. Do the rewrite first, and then you can start going from there and to do any factoring and canceling. What's really nice about that is now we have a multiplication problem, and well, we just went through how to multiply rational expressions together, and then that's all we're going to do. So really, this process that we have for division only has a very, very, very slight one-step difference, noticeably, our new step 1, to go through and solve this thing. So we're one step away from making this thing a multiplication problem, and then we're going to follow that process. I do again want to highlight and emphasize, because we are following a very similar process to what we did above, make sure that when you are multiplying everything together to be one single fraction or one single rational expression, Do not do any distribution or multiplying through of any kind. Yes, we are making one single fraction, but oh my goodness, leave everything fully factored and spaced out. Looking ahead, we are going to need to fully simplify this thing, which means we are going to need to fully factor it. So all you're doing with multiplying everything together, and if you distribute stuff together at that same time, all you're doing is making the fully factored form of an answer even harder to get to. So we leave everything separated, we leave it all spaced out, and then we go through and simplify this thing. Now I will note, you do have the option with the division process. This step 0 can be done right after step 1, right before step 2, if you'd like to do that. You will eventually have to fully factor the numerator and the denominator. It's just a matter of where in this process do you want to do that. So you do have a little bit of flexibility there. But I would recommend you write this process that we have here down for yourself. So you can take a note of that and reference that for yourself as necessary. And we're going to jump over and take a look at the 2 examples that we have written down here. Now for our first example, we are going to skip step 0. We're just going to go right to step 1. I think that's the main one we want to get written down here and nailed down here. So we are going to focus on rewriting this thing so this becomes a multiplication sign, and our second rational expression, or the thing that comes after the division sign, is flipped accordingly. So for our rewrite step, and again, this is the make it or break it step with all of these division problems. The thing before, the rational expression before the division sign, stays the same. The division sign becomes a multiplication sign. You can also write this with the dot. You could write it instead with a set of parentheses. There's a few ways you could do that. But the rational expression that comes after the division sign flips. The numerator becomes the denominator, and the denominator becomes the numerator. Make that a little bit better for there. There we go. And now I have a multiplication problem. And I can go through and use all the previously learned methods that we had for multiplying these things together to go through and solve this thing. So I am now going to go through and fully factor each numerator and each denominator. I personally like doing this when everything is separated out and spaced out. I think it's a little bit easier to keep track of everything. That's a personal preference though. So from the first rational expression in the numerator, I'm looking at the 10x minus 5, or 15 I should say. I can factor out a 5, and I'm left with 2x minus 3. In the denominator, I can factor out an x, and I'm left with x minus 5 in the denominator spot. The second expression, I can factor out a 2 from the numerator, and I'm left with 5 minus x. And in the denominator spot, I can factor out, looks like a 7. I'm left with 2x minus 3 down below. Now before I cancel things, you might be noticing and seeing that you can cancel things. I'm also noticing, ooh, I have an x minus 5 and a 5 minus x. If the numbers in one of these, or the signs in one of these, was flipped, these could cancel out. So me personally, I'm going to choose to rewrite the numerator up here, though it's your choice on which one you'd like to rewrite. So this 5 minus x, I am also going to factor out a negative 1, so I am going to do one more rewriting line here. I'm actually going to move this up here. We'll do this instead. So the first rational expression isn't changing. It's still going to be 5 times 2x minus 3 over x times x minus 5. But all I'm doing is I'm factoring out a negative 1 from the numerator of the second rational expression. So that 2 is going to become a negative 2. And then everything in the parentheses is just going to change signs. So the negative x becomes a positive x. The positive 5 becomes a negative 5. That's all that we changed. It's not something that is particularly obvious, but it is something that we need to be on the lookout for, because that is something that we can factor out and cancel out in these processes. And you will be dot points if you are not doing that. So be on the lookout for it. Pays to be take your time and go through these a little bit slowly to see that, I think. But now that we have everything fully factored in the numerator and the denominator spots, I can start canceling. So I have a 2x minus 3 and a 2x minus 3. Those each cancel out and become 1. I also have an x minus 5 and an x minus 5 that cancel out, and those two things become 1. Let's do a rewrite before we start multiplying things together. So my new first expression is 5 over x. The second one becomes negative 2 over 7. I can't factor and cancel anything else out, so now I can multiply everything together. I'm going to get a negative 10 over 7x. Again, I always check, can I factor and cancel anything else out or reduce anything down? No, I can't. So therefore, my final answer for this problem is going to be negative 10 over 7x. Our final example with this section is the expression x squared minus 36 over x squared minus 4x divided by x plus 6 over x minus 4. So I'm going to go through this one. Again, just want to show different ways and different methods you can go through and write this thing out. I'm not going to do any factoring with this problem until I get everything written together as one single fraction. You are welcome to do factoring beforehand if you'd like to. I just want to show you another way that you can write these things out. So, first and foremost, I still need to rewrite the problem as multiplication, meaning I need to get rid of this division sign and I need to flip the thing that comes directly after the division sign. So the first expression is staying the same. I'm still having x squared minus 36 over x squared minus 4x. I'm switching that division to multiplication, and I'm flipping the fraction that comes after it. So it becomes x minus 4 over x plus 6. Now again, let's say I don't want to factor and cancel anything until everything is one single fraction. So I'm going to start multiplying this stuff together. Great! You are more than welcome to do that. So let's condense everything down to be one single fraction. Now, as noted in our process, when you are putting everything together as one single fraction, absolutely never do any kind of distribution. What we're going to want to do is write the first numerator inside a set of parentheses, the second numerator inside a set of parentheses. First denominator in a set of parentheses, second denominator in a set of parentheses. And now I have everything written out as multiplying together. But I get the final parenthesis in there. So cool, we've got that. Now I can look at this thing and now I'm going to start factoring things out. Remember, you cannot jump to canceling. You must factor first. It is always factor, then cancel. Factor, then cancel. So can I factor anything in my numerators? Yeah, I can. I'm looking at this x squared minus 36. That is a difference of squares. So this x squared minus 36 is going to become x plus 6 times x minus 6. This x minus 4 isn't changing at all. I can't factor anything out from there, so it's just going to come down exactly as it was. In the denominator spot, I can factor this x squared minus 4x. I can factor out an x from there. What's left over? I have x minus 4. I did nothing to that x plus 6 down below. Or at the very least, I should say, I cannot do anything to that x plus 6 down below. In terms of factoring, I can't factor anything out, so it's just going to stay as it is. And now looking at this thing, I have everything fully factored. Only now can I start canceling things out. So I'm looking at my numerator and I'm seeing I have an x plus 6 and an x plus 6 in the denominator as well. So these two things can cancel. They each become a 1. I have an x minus 4 and an x minus 4. So those will cancel. And I'm going to rewrite this thing before I make too much of a mess with it. So what's now left over in my numerator? Well, I just have an x minus 6. And what's left over in my denominator spot? I just have an x down there. Everything else was 1s, so 1 times anything. It kind of just gets absorbed up to whatever the other thing was. Nothing changes. And now I'm looking at this and I'm seeing, okay, I have x minus 6 all over x. I cannot factor anything else out, meaning I therefore cannot cancel anything else out. So let's do one final rewrite just to drop those parentheses. We aren't needing them anymore. And therefore we have our final answer of x minus 6 over x. And again, if you were looking at this and thinking, well, hold on, can't I cancel the x's here? Did you factor anything out from the numerator? And did you factor anything out from the denominator? If you didn't, then you cannot cancel those. We can absolutely never pick and choose things to cancel in a rational expression. It is always factor and then cancel. So bringing us back to our overall set of notes that we have here, I'll erase our answers, or the covering for our answers, so we can see all of those. So remember, division is effectively one step away from being multiplication with these rational expressions. As you are going through them, make sure you are following the designated processes. These become very mechanical if you follow them. If you want to deviate from them, it's your call, but I think it tends to get a little bit harder if we're doing that, if we start deviating from that at all. So I would pause the video here if you need it to write any of these down for yourself. I'm going to try and get both of these processes in screen here for a second. So I'd pause it here if you need to. Otherwise, we're going to scroll down to some extra practice problems or group problems if you want to go through those. So I have these here. And again, if you'd like some practice with these, I'd recommend pausing the video here before I scroll down to the answers to each of these problems. I'm scrolling down now. We have our final answers written out here. I do want to note with these, again, all of these are written in fully factored form. If you are seeing problems in the textbook or other sites that you're going to and they do not have answers written out like this, they have everything, let's say, multiplied together here, everything multiplied together here, and so on. Just be aware that that's all they're doing. But for the purposes of what we're going through with this class, leaving your answers fully factored is perfectly acceptable.